Hi, welcome to my channel pibyme Maths. This is Baiju Vasudevan. In this video, we are going to solve January-February 2022 Pure Math 3 paper. Let's look at question number 1. Using calculus, find the x-coordinate of the stationary point of the curve with this equation. To find the x-coordinate of the stationary point, you need to differentiate it and equate it to 0. So how are we going to differentiate it? Take it as u is equal to 2x plus 5, v as e to the power 3x, u dash is just 2, v dash is 3e power 3x. Now apply the product rule. vu dash, that's 2e power 3x plus uv dash, which is 2x plus 5 times 3e power 3x is equal to 0. Take e power 3x as a common factor. You have 2 plus 2x plus, you need to multiply by 3. So 6x plus 15 is equal to 0. So you need to equate them separately to 0. You'll get e power 3x is equal to 0. Or 6x plus 17 is 0. Okay, the e power 3x is equal to 0 has no solution, because in order for this to be equal to 0, x has to be minus infinity. E power minus infinity is 0. So basically you can just ignore it. Take the other equation, x is minus 17 over 6. That's all. Question number 2. Show that the equation can be written in this form. We need to rewrite this equation in this format. Okay, so you can write, it's just a 3-mark question. You can write it as 8 cos theta is equal to cosecant is 1 over sine. Write it this way. Bring this here, so you'll get 8 sine theta cos theta is equal to 3. We know this double angle formula. Sine 2 theta is 2 sine theta cos theta, right? So if you multiply both sides by 4, you're going to get 4 sine 2 theta is equal to 8 sine theta cos theta. So you can replace 8 sine theta cos theta by sine 2 theta. 4 sine 2 theta. So 4 sine 2 theta is equal to 3. Sine 2 theta is equal to 3 over 4. It looks like this, right? Just a 3-mark question, that's all. Part B. Hence find the smallest positive solution to this equation. So instead of this, we are going to use this equation, because this has been derived from this, right? So we are going to use sine 2 theta is equal to 3 over 4. So find 2 theta, that's sine inverse of 3 over 4. Check whether it's a positive number. They want the answer in degree, so go to degree mode. Sine inverse of 3 over 4. So it should be sine inverse, not sine. Sine inverse of 3 over 4 and divide by 2. So you'll get theta is, they want the answer to one decimal place, 24.3 degree. That's all. Let's look at question number 3 now. Integrate this. Since it's a linear function, you can just write it as 2x. This is the rule. Always remember this. When you have a linear function to the power n, you can write it as just a rough integral, power n plus 1 over n plus 1 times 1 over the coefficient of x plus c. So in this case, the integral is going to be 2x minus 5 to the power 7 plus 1 over 7 plus 1 times 1 over coefficient of x plus c, which is 2x minus 5 to the power 8 over 16 plus c. Let's look at double A of this question. Show by algebraic integration that this can be written as ln a, where a is a rational number. So you need to write the final answer in the form of a ln m over n or something, okay, as a rational number. How are we going to integrate this? You look at the denominator, you have f of x, take it as f of x, 1 plus 2 cos x. When you differentiate it, you'll get 1 becomes 0, 2 cos x becomes minus 2 sin x, and you have this in the numerator, so you can apply reverse chain rule. Only instead of minus 2 we have 4, so we are going to adjust the constant. You see, I'm going to write 4 as minus 2 integral, just keep 4 outside. We need minus 2 sin x, right? So I'm going to multiply and divide by minus 2. 1 plus 2 cos x dx. Because the minus 2 cancel, you'll get the same integral, right? So why I'm writing this way? When you have a function at the bottom and the derivative of the function on top, you can apply reverse chain rule and write it as ln f of x plus c. Okay, so in this case 4 over minus 2, you have minus 2 outside, ln f of x and then you need to sub in the limits 0 to pi over 3 and write your answer as a single logarithm. So we have this step. I'm going to keep minus 2 as it is, sub in the upper limit, so you will get cos pi over 3 radian mode cos pi over 3 is 1 over 2. So ln 1 plus 2 times 1 over 2, that's gonna be ln 2 minus, when you sub in the lower limit, 0 in the place of x, cos 0 is 1, so you are gonna get ln 3. So it's basically minus 2 ln 2 over 3, but we need a single logarithm, so I'm going to put this minus 2 as a power using loss of logarithm. So 2 over 3 power minus 2 is same as 3 over 2 power positive 2, which is 9 over 4. So the answer is ln 9 over 4. That's all. Question number 4. The growth of a weed on the surface of a pond is being studied. The surface area of the pond covered by the weed, a meter square, take note of the units please, is modeled by the equation this, where p is a positive constant, t is the number of days after the start of the study, number of days actually. Okay, given that the area is a is 30 meter square at the start of the study, it means when t is 0, and then a is 50 covered by v t days after the start of the study. Show that p is equal to 2.4. So in here we are going to replace a by 30, t by 0, sub in the first condition. So you're going to get 30 is equal to e power 0 is 1, so 80p over p plus 4, make p as a subject, bring it here, 30p plus 120 is 80p, 80 minus 30 is 50p is 120, p is 120 over 50. We got the answer 2.4, just a 2-mark question. Let's move on to part B now. Find the value of capital T, give your answer to 1 decimal place. Okay, I'm going to write the equation. A is equal to 80p e to the power 0.15t divided by, okay, we know the value of p, right? Just sub in here. So write it as 80 times 2.4 times e power 0.15t divided by p e power this plus 4. P is this, e to the power 0.15t plus 4. Replace small t by capital T. Now use the second condition. A is 50 and replace small t by capital T. So A is 50, small t is equal to capital T, implies 50 is equal to 80 times 2.4. 80 times 2.4 is 192 e power 0.15 capital T. 2.4 e power 0.15 capital T plus 4. We are going to make t as a subject. Bring the term here. So 50 times 2.4 is 120 e to the power 0.15 t. 4 times 50 is 200 is equal to 192 e to the power 0.15 t. Okay, so when I bring this term here, these two are like terms. So 192 minus 120 is 72 e to the power, this is 200. So e power 0.15 t is 200 over 72. When you remove e, it becomes ln 200 over 72, and then divide by 0.15. So it's going to be 1 divided by 0.15 ln 200 over 72. That's 6. They want the answer to one decimal place, so 6.8 days. T is 6.8 days. That's all. Part C now. The wheat grows until it covers the surface of the pond. Find, according to the model, the maximum surface area. Okay, I'm gonna use the equation again. 80 times 2.4 times e to the power 0.15 divided by pe power 0.15 plus 4, right? Oh, that is t also in the power. To find the maximum value or the upper limit, you need to find out what happens when t tends to infinity. So in order to do that, it has to be e power minus t. So if t tends to infinity, e power minus infinity tends to 0. Okay, so you need to have e power minus t. So what I'm going to do, I'm going to take e power 0.15 t as a common factor. 80 times 2.4, I think we calculated it here, right? 192. 192 divided by, take e power 0.15 t as a common factor, you will get 2.4 plus 4 over this. Hope you understand this step. If you're wondering why I'm doing that, I can cancel this. So I'm gonna get a is equal to 192 over 2.4 plus 4 e power minus 0.15 t. We have e power minus. Now write when t tends to infinity, a tends to e power minus infinity is 0. This whole thing becomes 0. You'll get 192 divided by 2.4. 192 over 2.4 is 80. 80 meter square is the maximum possible surface area of the pond. That's all. Question number 5. We have a diagram given, looks like a quadratic function. We have a stationary point M and two x-intercept P and Q. Let's read the question. Figure 1 shows part of the curve with the equation y is equal to this, x is greater than minus 3 over 2. Okay. The curve cuts negative x-axis at P as shown in the figure. Okay. And then show that the x-coordinate of P lies between this. That's basically, how do you get the x-intercept? You replace y by 0, right? So when you solve this, you are gonna get the x-coordinate of the x-intercept. You are going to get the x-intercept of the function, right? That means you are basically finding the solution of this. So this is another way of asking you to prove that the solution lies between these 2 points. So take the function as f of x first. 6 ln 2x plus 3 minus x square over 2 plus 4. Find the value of f of minus 1.25 and f of minus 1.2 and check whether the sign changes from negative to positive or positive to negative, so that we can say there is a intersection with the x-axis in between these 2 points. So 6 ln 2 times minus 1.25 plus 3 minus 1.25 square over 2 plus 4. 6 ln 2 times minus 1.2 square plus 3 minus 1.2 square over 2 plus 4. Get these 2 values first. 6 ln 2 times minus 1.25 plus 3, close the bracket, minus x square, open the bracket, minus 1.25 square over 2 plus 4. You get a negative number, minus 940.94 dot dot dot, write it as less than 0. Okay, now minus 1.2 now. So what I'm gonna do, I'm gonna use the same thing, but I delete the 5. Now I'm getting a positive number, 2150.21 dot 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 positive. So now we need to write the conclusion. Okay, so how do we write the conclusion? We need to write there is a change of sign and f of x is continuous, therefore the x coordinate of P lies between minus 1.25 comma minus 1.2. You have to write the conclusion. Okay, next part. The curve cuts the positive x-axis at Q, as you can see from the figure. Okay. Using the iterative formula, this with x1 is equal to 6, find x2, and by continued iteration, find the x coordinate of Q. You have to show this step actually how you sub in x1. So x2 is equal to 12 ln 2x1 plus 3 plus 8 square root of. You need to show this, otherwise you will lose more. So 12, sorry, everything inside square root, right? Square root of 12 ln 2 times 6 plus 3, close the bracket, plus 8. They want the answer to 4 decimal place. 6.3637, 6.3637. That's for BI. For WI, you can just write the answer by continued iteration. So what I'm gonna do, 6 was the x1, right? Now I'm gonna go to 6, delete it, I press answer. So the calculator will take the x2 value, the new output as a new input. The reason output as a new input. All I need to do is just keep on pressing the equal sign and look at the decimal numbers, how it changes. Okay, this is gonna be x3, x4, x5, x6, x7, it got stuck at 4.1, xi got stuck at 41, this 4 decimal places. So 6.4142 is the answer. That's all. Part C now. The curve has a maximum turning point at M, as you can see here. That's a maximum turning point. Using calculus showing each stages of your working, find the x coordinate of this. So you need to take y, the function y, which is 6 ln 2x plus 3 minus x square over 2 plus 4, right? Yep. To find the stationary point, you need to differentiate it and equate it to 0. So when you differentiate this, you need to apply chain rule by taking this whole thing as x. So 6 times derivative of ln x is 1 over x. Don't put x, it's 2x plus 3 times, because we are applying chain rule, you need to differentiate 2x plus 3, so you will get 2 minus derivative of x square, 4 becomes 0, right? So you're gonna get 12 over 2x plus 3 minus x is 0, and make x as a subject. So 12 over 2x plus 3 is equal to x. Bring it here. You're going to get 12 is equal to 2x square plus 3x. So you got a quadratic equation. 12 is 0. And solve it. You're going to use the calculator to solve it. 2, 3 minus 12. Okay. The M has a positive x coordinate, right? This is supposed to be a positive number, so we'll take the positive number when we solve it. This is a negative number, ignore it. The next one, oh, okay, wait. The first one, is it a positive number? Yes. Minus 3 plus 105 over 4. So x is minus 3 plus square root of 0.5 over 4. You cannot write plus or minus, you will lose more. And write a step here, x is equal to minus b plus or minus square root of b square minus 4ac over 2a. That's all.